Okay, let's get started. Good morning, everyone. Thanks for joining in to this session. The session was originally planned for the BCP DR workshop, which Elite CISO members are undergoing. So that's like 10-hour workshop. It started yesterday, and it is 8:30 a.m. till 11 a.m. in the morning. And during the workshop, we kind of talked about that. Okay, for the cloud, what options are available for BCP and DR. So that's how I reached out to Lalit, and Lalit candidly accepted the invite to speak to Elite CISO members around BCP DR on AWS Cloud. Now, instead of just restricting it to the workshop participants, we decided to open it for all chapter members because it's all about learning and education, and that's what the prime focus of Elite CISO is, that knowledge should be shared with all. So having said that, we shared in all the groups, and we welcome you all to learn insights into this session. From Lalit, he has got great experience around various security offerings of AWS. So today we are going to do a deep dive into the BCP DR offerings of AWS. So Lalit, over to you. Thank you. Lalit, you are not
Right,
audible.
so somehow,
Yeah,
my microphone got muted. It's on now. Let's go ahead.
sure.
All right, so thank you, everyone. So today we are going to talk about BCP and disaster recovery. Some of you might be thinking why a security person is talking about, because one of the key aspects of security is protect and recover. So recovery is also part of security. That is very simple, and we'll keep it very simple, open to questions that how backup differs in cloud, and what are the common patterns, and what are the various architecture for DR in cloud. However, we are considering that not every organization would be completely in cloud. There will always be cases of hybrid approach where you have on-premise workloads as well as you are trying to build DR in cloud. So you might be running workloads at multiple locations. Traditional backup environment, we'll start with backup and then come to DR. Traditional backup environment, as we all know, there used to be a media server. Media server is required so that it can fetch data, or it can create a connection between D2D devices, our VTL or our tape libraries, and we can push the data. And then where do we take this data? Of course, an offsite backup, a data bunker we may like to call, or an offsite backup. This stored there, but then when we have to recover, we have to get the tapes and then have to start the recovery process. Sometimes it works, sometimes it fails as well. Well, the modern backup has changed in a way that it's an API-driven backup. What really API-driven means that it's no longer a mediation is required, no longer a media server kind of thing is required. Applications can directly integrate with backup services. They can directly talk over HTTPS, make API calls. It's simple, secure in a way that there is no D2D devices coming in between, and we can straightforward application have extensions which can directly write to the backup storage. Durable, I'll come to that. That's the most critical piece of backup, that whatever I'm storing has to be durable in nature. And variable cost. This is another factor of cloud, that as much as I'm storing, I'll only pay for that. So that it's around the promise of pay only for your utilization. So immediate backup, one of the key backup, we all know these benefits, but I just want to highlight one thing here, is of course cost effectiveness and other things. Unlocking insights from your data, that's a key benefit. As of now, if we are putting our data onto backup devices, we have to fetch the data back, load to a processing engine or analytics engine, and then we can understand what kind of data it is, what information is. The modern backup is such that wherever we are storing the data, we can directly query the data. We can directly run processing analytics on top of data while the data resides in backup mode. So that's a key advantage of backup in cloud. So what's the thing that's storing all this data? We need three things here. One, of course, there has to be low network latency. There has to be high speed. And second, the storage has to be highly durable where we are writing this. We don't want to create backup of backups. We don't want to get into that situation. So Amazon S3 and Amazon S3 Glacier, these are the two services which are designed for 11 nines of durability. In simpler terms, if we have storage racks in our data center, we have storage arrays. And if I'm able to create multiple storage arrays and replicate data between them. Now consider this happening across multiple data centers. This is a visual representation that there are multiple availability zones. Availability zones are, you can consider analogous to data center. However, each availability zone is a cluster of data center. That means more than one data center there. And the data is being replicated across these. However, at no point data leaves the boundary of a region. Region is, for example, Mumbai is one region. US has 5 regions. There's a European region in Ireland and Frankfurt. So the data which is being written on S3 is highly durable. What's the durability figure? Is 11.9 of durability. So I don't need to again create a backup of it. So that's our central service. There are two components here, S3 and S3 Glacier. Glacier, as the name suggests, is frozen. That means it's an archival. There's a lower tier of storage, lower tier in the sense of a cost-wise. Provide the same durability, but one is a online storage and second is a archival storage. That's a key difference between S3 and S3 Glacier. But before we go ahead and jump onto backup, we need to understand how our data center going to incorporate AWS cloud, how we are going to extend to AWS cloud, the network part of it. So this is our corporate data center, and there is AWS where we might have different accounts or different VPC. VPC is virtual private cloud. That's an extension of your data center that you have created in AWS. These are dedicated resource to you in AWS. How does it connect? There's something called transit gateway. Consider transit gateway as a routing device where we have what? Routing table, of course. So that means there are two interfaces like any router, interior and exterior interface. We define routing table where exactly my data center connects. How does my data center connect? Over internet, I could have VPN or could have a dedicated lease line from my data center connecting to AWS data center. So that's an architecture. Now the question might come from a backup and DR perspective is, what is the latency? If you are in Mumbai, if you are on direct connect within Mumbai, then we have seen less than 10 millisecond latency. If you are in other parts of India, we can always measure latency, but over VPN as well, it's like 30, 35 millisecond latency from New Delhi. So now it's also depend on the pipe that we are dedicating. If we are taking a direct connection, do we want to take a 1 Gbps connection or 100 Mbps, 500 Mbps? But then there is a way we can connect to AWS directly in a secure manner. Was demonstrate the outbound and other connection, but the key point here is either VPN or a direct connection. But then the question might come that I have a huge amount of data in terabytes or petabytes, and how do I move that data? For that, there is also something called a non-technical service called FedEx. In simple terms, it's called Snowball. Snowball is nothing but a NAS device which is shipped to your data center. You can hook in your data center, connect it, put the data on that, and send it back to us. So that mechanism is also available for one-time backup. Now, coming to the pattern, but what I'm going to back up, I need to understand it's written in a file format, in a file system. or it's a block storage, or it's a particular database I'm trying to back up. So I need to have that awareness of application type. So my application is, for example, is being presented via NFS or SMB. We provide something called a file gateway. A file gateway is nothing but like a virtual appliance. So there's an OVA file that you can deploy in your data center, connect to your applications, your file servers, and you have a local copy created in file gateway, and it asynchronously keeps on pushing data to AWS S3 bucket. So this is where a hybrid cloud workflow will work, and there's a low latency because the data is first written to your on-premise file gateway, and from there asynchronously it will keep on moving to S3 bucket. So we're solving file based application. Then there are tape gateway that you already have, a mechanism to have a file gateway where it can write to virtual tapes. So that tape library is also available. An interface, when we say tape libraries available, in virtual VTL interface is available. Then, of course, there's a volume gateway where I have a block-based storage. I have a block storage, and so I might have a file system. I have a block storage. Here we provide a different kind of gateway, which is called volume gateway. Exactly the same mechanism. Create a local copy and asynchronously keep on pushing to AWS. So this is a pattern by which on-prem, data center, and AWS integrate in terms of backup. Now, you already might have certain tools running like Veeam, or if you're using virtual environment like VMware, or maybe Commvault. Dell also provide NetApp, Rubrik, Veritas. If you already have backup softwares running, we can also integrate with them. So this is what it shows, that there is a corporate data center and you already have a setup. You don't want to disturb that setup. The workflow has already been defined. You go ahead and integrate your backup softwares, the third-party partner software, into AWS and move through the network channel of course, VPN, AWS Direct Connect, or Internet. Now the interesting part, that was a backup part. The interesting part is disaster recovery. How do we look at disaster recovery? We all have learned disaster recovery as a three-way DR in our starting days when we all started, that there is a DC, there's a near DR, and there's a far DR. Near DR is where all the synchronous storage replication happens. We talk about latency, okay, there has to be less than 100 kilometer, practically it's less than 60 kilometer, typically 10, 20 kilometer distance near DR, which is like a bunker site. And then there is a far DR. That's the concept we all have learned. Now, in case of a cloud, how does it a little bit different? Traditional disaster recovery, traditionally it's investment heavy. That means I need to have a large storage arrays at both the side and maybe equal storage array. And then I need to have my application servers built, running. Just keeping the lights on is too much of cost. Now, this changes in cloud. There's no upfront hardware investment needed, and we only pay for, we can have lower configuration machines, which could be scaled up as and when required. And of course, it can be tested easily. It's easy testing rather than we have seen certain scenarios in our career. We all have seen where the DR actually has not kicked up. Now, just to look at it, the first thing that we think about when we talk about RPO, disaster recovery, is RPO and RTO. On a lower side, there's a backend restore process where, of course, RPO, RTO is in hours. We need few minutes of RPO, RTO. There's something called Pilot Light, and we'll start getting into these architecture now. Pilot Light provides minutes, like 10 minutes, 20 minutes, typically less than 30 minutes of RPO, RTO. RPO could depends on the checkpoint where we have our checkpoint, how much is the latency and all. RTO is something that to get operationalized, which could be essentially very fast. Then there's a warm standby in AWS. That means within few minutes, typically less than 10 minutes, we are able to up and running, and there's a real time. And this is the method where, or this is the pattern that no longer there are active passive sites, there are active sites. So essentially DR, the old DR, as we all know, is no longer running. It's dead. It's active site. Quickly, availability concepts. We all understand high availability, 24/7 backup, data is safe, I can recover, disaster recovery. In case of a major disaster, I might switch to a different location. Within AWS, how does it work? Within AWS, as I mentioned, that there are multiple availability zones. If a database is running in one zone, there is a replica and there is a slave running for that in another zone. If there are EC2 instances which are running EBS volume, which stores the data, they can be replicated within the same availability zone as well as across availabilities. Now coming to the pattern, the first pattern is Pilot Lite. This is how Pilot Lite will look like. We have a corporate data center, the proxy caching server, and there's application server. It's a two-tier architecture, let's say, application server and database server. So web app and our database. The database server need to be replicated continuously and synchronously. So now synchronous replication may or may not work depending on the distance and the latency between the two sites. However, from India perspective, majority of our data centers are centered around Mumbai, or they have a corporate office in Mumbai, where there's a dedicated line could be taken and latency could be less than 10 milliseconds. So which makes it possible to do a synchronous replication. So there's a replication keeps on happening here. If it's not synchronous, then of course there is some kind of a recovery point comes in. So there's a replication happens here. The size of the machine does not matter here. Here we might be running a database with a beefed up machine, really high on CPU RAM. We don't really need to do that because this application is actually going into storage. So I could have a smaller instance size. Similarly, my application server is pre-configured. Whenever I apply a code change here, I'll also apply code change in cloud. And I have other reverse proxy or a caching server or a web server, a front-end server configured, pre-configured. However, they are not running. If they are not running, they are not charged. So they are not costing me. So only this machine where I'm replicating data is costing me. In case something goes wrong with my data center, we could initiate recovery by starting these two machines, and either we are keeping the same instance size. A beefed up machine, I would not recommend that we keep a smaller instance size and we can add additional capacity as required. So DR, we might say that we might run at a lesser capacity, or if I need to increase the capacity, I can always change within minutes. I can change the instance size and be fully functional. Of course, there is a DNS change cutover that happens that will also come into picture. So this is within minutes, less than 30 minutes, we can do around 10 to 12 minutes. It's doable. That's Pilot Lite, where you're running with a very small machines. And second is a warm standby, where I'm running a scale down standby. That means a smaller instances, same concept applies. I'm replicating my database. However, I'm also replicating any kind of file changes as well. So application data source cutover is there. That means my application server, my proxy web front end is also up and running. However, they are running at a less, in terms of a hardware configuration, they're running at a much smaller scale. I could always change that scale. Being in cloud, that's a big advantage, that I can always increase the resources. However, they are active, warm standby, so within few minutes, I can just have to, I have to just cut over DNS and point to my cloud. All my traffic goes to cloud, and I can start serving traffic. The moment that happens, my DNS takes over and my production is scaled up. Hot site, the same capacity we run, and active. Or if you look at different way, then I'm serving maybe 50% traffic from here, 50% from here. But that's not really a great strategy, because if one of the site goes down, I'm at a 50% capacity. So always I have almost like 100% capacity here, 100% capacity here. That's an ideal scenario. I can't be like 50% here, 50% here. If one goes down, I'm actually degrading my services. So it's like kind of likewise replica, and the same replication using mirroring replication, maybe if we are running Oracle database or Microsoft SQL, maybe the vendor specific replication tool, or we also provide tooling around it. This could be a application level replication or a block by block replication as well. So the same way now active site will work, and my Route 53, which is a DNS service, is acting as an arbitrator where it's deciding, okay, this traffic goes to this data center, this traffic goes to the cloud. If it goes down, my ability is that I can now send all the traffic to AWS cloud. But the point here is that I may have different kind of application. Not all databases could support likewise replication, or there could be replication challenges. To solve those problems, that we might have different kind of application running, some bare metal, something on Hyper-V, something on VMware, ESXi, and different databases. How do we go about this? So Cloud Endure is a company that we have acquired almost 2 years now. So Cloud Endure is a tool built for disaster recovery. What it does, it can replicate from any source. That means any database, any file system. Supports wide range of OS, Windows, or different flavors, Linux, different flavor. And it provides a failback option to cloud to on-prem. That means it's a two-way communication. It can move from a cloud to on-prem as well as on-prem to cloud. It provides me continuous replication, reliable, robust, predictable, non-disruptive. Yeah, one of the thing mentioned here is protection against ransomware. In case of some machine got affected, I do have another copy. Highly automated. That's mean there is an orchestration workflow. There will be a dashboard which is being provided where I can see the status of replication, which workload is running where. I can orchestrate the entire DR. Improve recovery objective and reduce TCO. It's a straightforward. I have to point. There's a connector provided with Cloud Endure. I have to provide I have to define my application which need to be replicated. Once I do that, I can orchestrate where the workload is going to run from, which will be the primary site, which will be the secondary site. It supports both failover and failback. We'll install an agent for Windows, Linux. Replication starts. First, it goes into a staging area, and then we create a blueprint. That means it's not only my storage which is being replicated. I could also create a blueprint for my applications as well. If my application server is running, my web app is running, my proxies are running, it can capture configuration for all of them and create a similar environment. Of course, we can test the target servers, launch them, convert to machines, so it write them as a storage. Because if we look at in virtualization what we have achieved, that my server is nothing but a file on a storage, where in runtime it gets a CPU, network, and memory. So it's a file. So we get the same configuration and maintain those configuration. We can test those configuration that everything is working, and then of course we can do cutover and failure. With Cloud Endure, there's no reboot or there's no performance impact, no application configuration required, just the agent which is required on the target machines. If we need to make any changes, we can of course always test those and make those changes. This is how it will work. At the source location, the boot volume and data volume, and there could be what it's trying to show is trying to show that there could be Windows server, Linux server, or there could be a specific database running. So there are specific application-based agent as well, not only the OS-based agent. So for example, Oracle CE agent understand the Oracle database structure. There's a continuous replication. There's a staging area where we keep on replicating it. From these staging area, we can build our servers, and within few minutes, my entire infrastructure is ready. The whole idea here is, since I'm writing it to storage, there are no server involved here. I reduce servers are only there, a couple of servers here. I reduce my DR side compute cost by 95% plus. So only my replication servers are enabled. Application server, web servers, database server, I don't need them running. The big advantage is that Cloud Endure has worked out earlier. If we are running DR for databases, will require 2 licenses. Right now, it will be a cutover kind of thing, and Cloud Endure has sorted out the thing that only 1 license is required. If this site goes off, if my traditional site source location goes off, here I'm going to bring only 1 instance of that database. So my license cost has reduced significantly. So there is a continuous replication with sub-second RPO. We could do a test as well with Cloud Endure. There's a possibility that you can always check whether certain setup is working or not. You can orchestrate and you can visualize the entire process. So there's a self-service DR dashboard where in earlier days we have heard of one-button disaster recovery kind of things. So this is a kind of a turnkey solution for disaster recovery, where once configured, we can visualize the entire replication setup, how much time it's going to take, and simulate failovers. Now, there were some questions and challenges around pre-DR modernization architecture, like how do I securely transport data to AWS? One, we could always have VPN if we are not using Direct Connect. Second, Direct Connect is a dedicated lease line from customer data center to AWS, where we could also apply encryption. Now, other option is that we send you a device, which is a NAS device, and you can put data there. It is TLS protected, it's tamper proof. If that's a one-time process and it's being shipped back to us, where we upload all the data into your account. So that solves the transport challenge. Now, to keep the data in sync, once the initial seeding is complete, of course, we'll set up the replication for that. No need to pay for unused compute rather than run active sites. Different replication for database, for file system, for object storage, for block storage, all of these replication connectors are available. With Cloud Endure, of course, we can securely transport data to AWS. As I mentioned, Direct Connect and Cloud Endure also provide own encryption method here. Continuous data replication, well, after one time data movement, you could start your continuous data replication from the checkpoint. This will be block level replication. And then there's no need to pay for additional servers and infrastructure, which was required earlier for application for database server. That's not required now. Multiple replication, understand different OS, has support for various flavors of Linux and various versions of Windows. There's an orchestration engine. That means I can define my entire DR and cutover or failover. It can also convert on-premise a VMware hypervisor to Amazon EC2. If you're running on VMware, it can also convert VMware virtual machine into EC2. So that conversion also is being taken care by Cloud Endure. So you don't need to do a kind of a lift shift of first create a OS here, machine here, and then replicate data and point data to application. So that process is not required. So it does not require any kind of a boot process change, guest agent installation. So that's where we come to the end. I want to open it for questions. Idea is that these are various patterns, and depending on where we are, we might be running in data center or we might be running in AWS. In data center, there could be different configuration, different databases or virtualization. So those virtual machines could also be converted to EC2 instance. One is a migration is also possible with Cloud Endure, and a continuous DR is also possible. It's like site recovery, or in VMware, there's a site recovery manager, SRM. All those features are today. Capabilities are available in cloud. With this, I'll open for questions. I'll check the chat.
Yeah, there are few questions and comments on the chat, so maybe if you can go through those.
Sure, I'm just looking at that. All right, so Kiran has asked, do we need to have DR environment when all the production workloads run? 1 second. When all the product run in multiple AZs, can't this design be targeted as DR compliant by BFSI regulator? This could be the best use case of DR. Yes, it can be. So Kiran, to answer your question, yes, that's exactly the purpose. There is a BFSI regulators, and within the India, Mumbai AWS is running and your data center is running, you could have a continuous replication. That is possible. And there is something else which we have also announced for India. It's launched. Is something called Outpost. That means within Outpost is our service where we supply you hardware. We'll supply you a rack and hardware where we are going to control the configuration and going to install it for you. And you could have a replication between Outpost. Outpost is considered as in your data center hardware infrastructure supplied by Amazon. And you could have a replication or your own choice of, or your existing investment that you have, you could have replication with Cloud Endure. Okay, commercials totally on consumption of storage or separate charge for downloading. All right, so Sanjeev, data in and data out, these are the two things that applies. There's no charges for data in. For example, when you are doing backup to cloud, let's say you're moving terabytes of data, there's no charges for data transfer in. So that means there's only charge for storage that you are going to consume. However, there is a charge for data out when you are going to, let's say you have written data in AWS and you're moving that data. That's a bandwidth consumption. So there's no data in charge. There's a data out charge. So Sanjeev, to answer your question, only the storage in this case, only the storage consumption is charged. Okay, let me move to next question. Do you need to have DR environment when all the function? Okay, that's the same question. Sanjeev has asked a very pertinent question today, seeing the lot of ransomware and malware kind of attacks happening. So Sanjeev's question is, if my on-prem server is got corrupted due to malware, will it override the AWS backup? See, if we are going to continue the replication, if we have not detected it, of course, it's going to write the same thing. However, in cloud, there is always a checkpointing available. Now, checkpointing could be configured within minutes or a day wise. So you're protected in terms of that there are enough checkpoints, and you can always choose, okay, I have to go before this timeline. So that is very much possible. So it does provide protection against malware in that sense. Okay, mux to all. Recently, there was an attack on a corp house. They had real-time backup through VPN that was also compromised, and a hacker had access to backup damage. Was end-to-end. What are the SOPs to avoid such mistakes? Yeah, true. So if you're replicating, and let's say there is a file, malware is causing a file system change, and it's encrypting all your files. The same thing is set up for replication. One, it has to be different permission, different checks. The same scenario which Sanjeev asked, that there are enough checkpoints and you could utilize those checkpoints to recover the data. Okay, VPC Flow Log. So Malini is asking that the question is not very clear to me, but to answer this, Malini's question is about VPC Flow Logs during cutover or failover. Let's say within AWS as well, VPC Flow Log is actually a separate, separately maintained. That means there is no, in case any of the availability zone goes down, there is no impact on VPC Flow Log because we have a separate channel for that, and logs are highly durable and available. It does not get impacted if a machine goes down or even an availability zone goes down. Unless the entire region goes down, VPC Flow Logs are there. In case a region goes down, there is also cross-region replication, which could be set up. But VPC Flow Log is a separate channel. For pilot light and hot standby cases, of course, you don't need to configure VPC Flow Log separately. Oh, okay, so there's the next question is AWS VPC Flow Log, CloudTrail logs to SIEM. Yes, there are mechanisms, and we can continuously push AWS platform logs to SIEM for analysis. There's another question that there's a tally server in a data center and we want DR set up for that server. Now, depending on what kind of DR, do we want a backup? You can always simply just take the backup and put it on AWS, or you could have a replication happening at a file system using Cloud Endure or using your own tool, and you could always replicate that. You can also have a configuration changes. However, to keep the cost low, you have to manually make configuration changing to both the sites for tally server. Govardhanan is asking, can you also help us to understand about encryption on storage and how to manage the keys? Now, encryption applies for storage. One, there could be a block by block encryption at a storage level, or there could be database level where we are choosing particular column to be encrypted. I believe the question is more around how to manage the keys for that. We do provide a service called KMS. KMS is a highly available key management service, which is behind the scene. There is a HSM working. So out of hardware security module, there's hardware security modules which are running in a clustered mode. We have created a service called key management, KMS. Now this key management stores the key hierarchy. That means there is a master key and there are data keys. The master key could not be extracted out of these devices. How do we know that? This has been validated by various compliance like FIPS 140-2. There are multiple levels here, level 1 to 4. The KMS applies to level 2. However, we do provide dedicated hardware security modules as well that provides level 3. So keys will be stored in KMS, and KMS does integrate with all our storage services and servers. You could also bring your own key. How to do file level recovery in case of Cloud Endure? Bhupinder Singh is asking, how do we do that? Now, in case of particular file, as I mentioned that earlier, what used to happen that there is a block by block replication, and we have to recover the entire storage block or entire storage volume to now go inside and bring a file. Even for our file gateway, it is possible, because now what we are doing is we understand file level and we do get a listing. So it's possible to get a listing of the content which is there. Now it is queryable. The content is queryable from storage. So this is very much possible today because the awareness is at file level. And what are the various file levels? So we can, there is a small kind of a middleware which is we could write, and we can populate the inventory of all the files. Okay, how we'll do the data protection against ransomware in data sync? I think we have discussed this, that there are various checkpoints. The moment a malware attack, before that you can always recover because there's a data sync happening. But in cloud, there's a multiple checkpoints available, and you can always go back to the good state. No, Cloud Endure is, so Ranjan is asking, is Cloud Endure a must to use AWS? No, Cloud Endure is not must. You could always build your own way. Cloud Endure is something where you want a complete kind of orchestrated DR. Cloud Endure provides more value in terms of it will save you money in terms of you don't need to configure servers for replication. Cloud Endure does take care of that. So a cost benefit analysis is something that could be carried out, but Cloud Endure is not a must. It's an optional thing depending on your requirement. Is deduplication feature available? No, deduplication feature is not available, Sanjeev. For that, we have to rely on a partner solution. AWS Direct Connect is provided as MPLS connectivity. Can we have AWS Direct Connect as one of the hub in our existing MPLS circuits? Yes. So we do, Gopi, we have multiple DX partner like NetMagic, GPX, Sifi. These are our partner. Airtel. These are our partner for Direct Connect, and they do provide these features.
Lalit, we can take just one last question.
Okay, looks like there are 3-4 questions. I quickly read it and. Okay. One moment. Okay, despite all this feature, there are still some customers who insist that data shall not be stored in cloud. What is your view on that? All right, so I'll just take this question. Suresh has asked an interesting question that despite all the features available, there are still some customers who insist that their data shall not be stored in cloud. What is your views on this? Now, Suresh, our view are very simple, that business should comply to the regulation, to the guidelines provided for their business industry. So, for example, if there are RBI guidelines around data residency, the data should not move beyond the boundary. You should have a complete control and ownership of the data. You should be able to demonstrate that you have controls over data. Now, all these things are possible in cloud. Now, I would say that when people say in cloud, we need to question, or we need to ask specific question that what is the key challenge? Is it a regulatory compliance? So there is a RBI compliant workload runs in cloud, because we could restrict data to Mumbai region, which meets the data residency requirement. Plus, there are all kind of encryption requirement. And the key message I want to give here is that you own the data. Who owns the data is customer. You have complete control over the data, and you can decide where to store the data, how the data is processed, and how long to keep that data. Right. So I think there will be more questions. You could always reach out to me. My email ID is lalitk@amazon.com, or you can always take my number from Vikas, and we can always speak on one-on-one basis. With this, I think over 1 minute, but thank you so much for your questions and time for this. Thank you for inviting me.
Thanks, Lalit. Amazing session. Appreciate your insights on this. And since we have taken the recording, so this will go on Elite CISO's website and YouTube channel, so participants can later on view it there as well. Thanks everyone for joining. Bye for now. Thanks, Lalit.
Thank you.